oftentimes they decide not to take action at all. And so that was called ISWA, Integrated Space Weather Analysis. And so that's where we're doing all this forecasting from. So now that I've talked a little bit about some of the exciting things happening in science, I'd like to switch gears to something I'm really passionate about, which is making science more accessible for people with disabilities. So this is something I think needs to be a bigger focus in the world. And one cool way to do this for blind audiences is through 3D printing. And so I'm really excited that these printers are over here. That picture you're seeing up here, we actually have models of right now. So feel free to come up afterwards and feel these. What you're seeing and feeling is a model of the constellations that was designed for a tactile planetarium show. So this model was developed by a team in Spain, and then I worked with COSI, which is Columbus, Ohio Science Center, to implement this tactile planetarium show there. And so it's not just a show for blind audiences, but anyone who wants to come and experience sort of a more immersive way to learn about astronomy. We also added visuals and captions so that deaf and hard of hearing visitors can experience the show as well. And both of these printers are actually currently building these domes. And I'm really excited that they have this type of printer, because the ones I work with are MakerBots, and it really sounds like robots are murdering each other when it runs. So this is a big improvement. The ones I'm used to are very, very noisy. So that's nice to have here in the background. But that's what's happening here. And this is a really useful tool when talking about making planetariums more accessible. Another thing we can work with are galaxies. So we know our universe is full of these big, beautiful galaxies. And one of the problems with astronomy is that it's often misperceived as a purely visual science, right? You think about people looking through a telescope, and that's about all we get. But there's so much more to it, and there's so many more ways to see and to experience the universe. And so one thing we can do is take images of galaxies and convert them into 3D prints. And so if you haven't gotten the chance yet to check some of these out, please feel free to come up at the end. These are all 3D prints designed from real data from the Hubble Space Telescope. So this is a project led by the Space Telescope Science Institute in Baltimore, Maryland, and this is the Science Operations Center for the Hubble Space Telescope, as well as the new James Webb. Once it launches, it'll be run, all the science will be run by this center in Baltimore. So what we do there is we start with a real image taken by the Hubble, such as this here. This big pretty one is called the Whirlpool Galaxy. And then I pull it into a specialized software developed by this team at the Space Telescope Science Institute. And this software is pretty cool because it allows me to look at the galaxy and paint its different components. And so what I've done here, I've painted where its spiral arms are, like one might do in Photoshop, and I've also picked out any parts where there are different structural components, such as star clusters or the central bulge of the galaxy. And I've identified all of that, and then the program takes what I've told it and converts that into textures. And so it takes the spiral arms and gives it a very bumpy texture. And then in between those spiral arms, it gives it a smoother area for the gas and dust that separates the arms of the galaxy. And so this is pretty useful because then I can pull that into a 3D printable file for a printer, such as one that you might see there, and then we can print. So this is just little videos showing you what that printing looks like, but we've got the real thing right here, so we don't even really need these. But as you can tell, this one's going pretty quickly. These prints can take a whole day just to do. These have been kind of popping them out, but these are such a detailed print that takes many hours to get. And they're all split in half because we want it to be a bigger thing for people to be able to feel, especially if we're working with people who are blind and can't see it otherwise. We want to make sure the textures are distinguishable. And so we split the print in half, and that way each half can be as big as possible on the 3D printer's platform, and then we glue them together, sometimes more messily than others. So sometimes it goes wrong, right? So I had a couple bad days at work where I showed up to that. So you kind of have this horrifying spaghetti mess that can occur, right? So these 3D printers are very finicky. And my Ultimaker, that's the type of printer this is, it didn't like me at all. But when you do it right, and when you fix all those problems, you should get something like this. And so that's some of the prints we have up here are depicted above. And the important part of this project to me is sharing them with people. So a lot of what I'm excited about is doing outreach. So I organized an event at the Maryland School for the Blind and had students not only experience them, but then provide their feedback on it. Because I think it's essential that all of this work is being guided by advice from people in the communities it's designed to benefit. So that's a big part of it for me. So I also worked with the National Federation of the Blind and a camp that was happening there for high school students, as well as organizing an event at the Smithsonian National Air and Space Museum, where we had our prints right under a full-scale model of the Hubble. So that's what you see on the right. That's how big the Hubble Space Telescope really is, and you can see that down in DC. So that's some of the things I've been working on in the past. Moving forward, I just wanted to mention briefly some of the other projects that'll be taking place. So